Good morning, everyone, or good afternoon, or almost afternoon for everybody. My name is Daniel Hargreaves, CSI Electronics Chair and Treasurer for CSINext, and we're excited to have sustainable building envelope performance with self-sealing fasteners and anchors, presented by David. And he told me his last name, and if you see my screen, you'll see I'm kind of mobile at the moment, or maybe my camera's off for your all safety and sanity. But with that, there's a question and answer box on the Zoom meetings. If you want to fill those out, we'll try and answer them in real time. I will be back to where I can read those off for David in about 20 minutes. But I will be here the whole time for the presentation. And at the end of this presentation, there will be a survey. Just click to navigate to the CSINext site. You'll get a choice to stay at Zoom or go to CSINext. Go to CSINext, fill that out, and we will register it for the HSW and AI credits and send out those certificates for those who need them. And with that, I am going to hand it off to David and put myself on mute, turn the camera off if it was on.
Thank you so much, Daniel. Really appreciate the introduction. Hello, everybody. Thank you for taking time out of your Friday to join me in presenting this for you today. I know my name tag says Brad Gump, but my name is actually David Boyd. I'm pitch hitting for Brad today. And as Daniel mentioned, the title of this CEU course that we're putting on today is called Sustainable Building Envelope Performance with Self-Sealing Fasteners and Anchors, and I'll get into what that entails. Just kind of going through the first couple slides, just some housekeeping stuff that I'm sure you guys are all familiar with. So I'll go ahead and kind of run through this. So the purpose and objectives for this CEU course today is sustainable building envelope demands high performance from proper insulation, continuous insulation, and air, water, and vapor and control layers. So we're kind of ask a couple of questions. What happens when thousands of holes are made in these materials with blind fastener penetrations? The sequencing of these layers, how does that differ between subcontractors? How does that differentiate what products are used to install each layer? What sequencing issues can be avoided? When can they not? And just focus on how self-sealing fasteners can be used as a solution to these issues and help mitigate, potential damage or inefficiencies in these types of systems. So the objectives that we have today at the end, we would like participants to be able to describe the functions of a wall, of the exterior building envelope, the air, water, vapor, and thermal control layers that are essential to these walls. Explain how fastener penetrations cause damage. They permit air and water to leak through control layers, resulting in, diminished performance, whether that be through mold or rust or just decreased energy performance. Which fasteners are capable of self-sealing? What is the correct product to use if you want to manage moisture, increase your energy efficiency by reducing thermal bridging, and similar things, and then kind of discuss strategies to specify these fasteners. How can I find these? How can I plug this into my specification and make sure on the job site that they are getting the correct product? So the contents, what we're going to go over is just an overview of a sustainable wall, what we believe that looks like, composition of the wall, the various layers from the studs outboard. Why does it matter to you? Why should you be concerned about these fasteners and the penetrations? Self-sealing fasteners and anchor solutions, so kind of what is available to the market. And then kind of the testing and specification of these particular anchors to make sure that they're actually doing what they say. So walls serve three primary purposes. The most important function of all is going to be structural. So structural support means that the foundation is able to support the structure's weight, and the walls are load bearing. So that would be dead weight. So the structure can support gravity. It can support the roof over its head. Then we've got dynamic loads. So live load is what that might be called. So that could be, snow, seismic events, wind, rain, occupants, other things inside the building. The second key function of a wall is going to be climate control, or like energy protection. So we use a lot of energy, both heating and cooling our homes, climate control. So the building envelope protects occupants and contents from the elements, and then helps to ensure that this conditioned air, whether cooled or heated, remains inside and is not able to escape, basically causing more use of energy, whether that be fossil fuels or electricity. So basically, it serves to keep the inside inside and the outside outside. Also, pretty closely related to the wall's function to maintain that climate, that energy use, is managing moisture. Water is a relatively damaging substance when you think about it. If it gets inside, it can rot wood, it can rust metal, it can do all sorts of things. So one of the key benefits of the wall is to keep air and water out. A properly constructed wall is one of the key aspects of sustainable building as well. Just helps to conserve energy while providing occupants, comfort, and healthy indoor air quality. And the third key design or key function of a wall is design. So this is purely for aesthetics, and this can do a vast majority of things, whether that be cultural identity, character, just looks. People enjoy looking at buildings that are pleasing. They feel good when they see things that are aesthetically designed. These things can show the personality of architects, of the people that live in these cities, and just show tradition and modernity. So it's kind of a cool way to express just local personality and things like that. So what are the essential components of a wall? So I'm sure some of you are familiar with Joe Stiebrick, legendary building scientist. So he came up with what he called the perfect wall. So this wall consisted of a structure. So that would be, your studs, whether that be wood studs, steel studs. It could be like a CMU backup, something to support the loading of this wall. The second would be the control layers. So that could be for water, air, thermal, vapor. So think about like your air and weather barrier, an air barrier, thermal insulation, things like that. And then the final layer would be the cladding. So the cladding serves a variety of functions that could be aesthetic. So it's the look. And it also serves to shed bulk water away from those control layers. It is possible that some of these layers can be combined into one. So you might see your sheathing layer, your control layer be insulation. It could be the sheathing, and it could be the air and weather barrier. There are some products that will do multiple things and integrate into one. So now we're going to kind of break it down a little bit further, the way that these multiple layers are sequenced. A lot of times they're going to be multiple individual control layers. So I would say the most common assembly that we see is going to be steel studs. You could have some sort of gypsum sheathing. You might have a sheet applied or a peel and stick air barrier over top. Then you're going to have some form of thermal insulation. So that could be polyiso, XPS, mineral wool. You're going to have a cladding support system that could come in many forms, like a metal hat channel. It could be lath for stucco. It could be wood strapping, like a 1x4. And then some sort of cladding is attached over top. It could be vinyl siding, brick, ACM panels, stucco. So kind of what you might notice is that there are a lot of complex variables. You look at all these materials. Are they compatible? How are they installed? What are their weaknesses? So there are just so many complex options. You either think about it, there's hundreds and thousands of permutations of materials and manufacturers and installation. So it's really something that we have to be cognizant of when we are designing walls to make sure that the products that we're using together are compatible. So fasteners and anchors. So as a fastener manufacturer salesperson, we often find that fasteners are an afterthought in a lot of cases. People know that they need the insulation, they know that they need the barriers, but oftentimes they don't really go so far as to think how the materials are attached and kind of what the proper fastener is. And this is a detriment in a lot of cases because fastening is very necessary. It's something that you need to attach these layers, and if it's not done in a thoughtful way, if the proper products aren't used, you could cause damage to the structure and potentially the long-term health of the occupants as well. So they securely attach all these components to the wall, and unfortunately they do bring challenges as well, because a lot of these materials are designed to keep air out. They're designed to stop thermal energy from conducting through the building, but they're creating holes. We're creating thermal bridges. So we have to make sure that even though we are attaching this insulation structurally, we also have to make sure that we're concerned about these thermal and moisture disadvantages as well. So let's talk about kind of the impact of moisture in the construction industry and kind of how much of a problem it is. So we've kind of noted already moisture's impact on buildings. So that can come in the form of rust or mold. You're degrading wood substrates. And also, the health of occupants. If you have mold, obviously that is not healthy for humans to breathe in long term. And so it's just adverse for humans. So we have to make sure that we're mitigating water. So moisture issues also have a huge impact on insurance claims and litigation in the construction industry. Researchers found that water is the second most common cause of property insurance claims, and it is the most expensive type of insurance claim, and accounts for about 70% of all construction litigation and costs the U.S. about $20 billion annually. The data also suggests that poor workmanship, poor supervision, and poor inspection of trade contractors during construction is the source of about half of these defects. So it's people, not paying attention, not using the right products, not taking care when they're doing these installation. So it's all very preventable. So specifying the correct anchors and fasteners is kind of a way to help protect these penetrations and prevent possible litigation from occurring and preventing moisture from infiltrating the building. So let's talk about the perfect installation and kind of this sequencing of these layers. So when you think about all these layers being attached, you look, you can see in this top right picture, that is a gypsum board that has an integrated water-resistant core in it. And then they're going to flash those seams with a liquid sealant. So that's going to serve as the structural sheathing as well as the air and weather barrier. But then you look at the bottom two pictures, they're putting insulation on over top. So these layers beneath that are supposed to serve as the air and weather barrier are being, penetrated several times via the attachment of these insulation. So that's a problem. What happens when this contractor shows up next and they're attaching this insulation over top over this, otherwise perfectly installed air barrier? Whose responsibility is that? The air barrier contractor could install this material to a T. And then the insulation contractor says, well, it's not my job to maintain that. I need to attach the insulation. So, kind of who's on the hook for that? Whose problem is it? So let's talk about a perfect installation and then kind of the layers that go over top. So this is a project that I was a part of where they did a peel and stick membrane on top or on the sheathing, and then put insulation over top. And then we've got it numbered here. You can kind of see there is a hat channel system going over top for the cladding. So we kind of just go down the layers. The polyiso was mechanically attached over the top of that orange layer. And then we have the hat channel being installed over that polyiso. So what's happening here is that these fastener penetrations over that air and weather barrier, while the insulation and the cladding attachment over top are basically just poking blind fastener penetrations through that layer. And there's really no way to treat those. Once the insulation goes up, once the cladding goes up, there's no way for you to access the air and weather barrier anymore to treat those fastener penetrations with some sort of tape or perhaps some sort of liquid applied sealant. So really the only option would be to, if there was some sort of litigation, to basically remove the cladding, remove the insulation, patch those holes, which is a big deal. That's a lot of labor cost. Now we kind of talk about sequencing problems. So that basically kind of means the way in which these layers, these control layers, are sequenced, the way they are installed. So the project here was built with a integrated product where the air and weather barrier plus the insulation product was included in one. It's basically a foil-faced polyiso. When it comes to sequencing, you can potentially have leaks that occur if different subcontractors are not considering how their install affects the layers that were previously installed before it. So in this case, the insulation insulation and weather-resistant barrier product was installed first, and then a hat channel system for a rain screen cladding attachment product was installed over top. And they didn't do a very good job. You can kind of see there is, some sort of sealant that they tried to apply, but they didn't take care to detail this product, so it eventually caused leaks. They had to remove this panel, and there's actually loss of occupancy post-construction. So it was only about a year or two after this was constructed that they lost occupancy, and the contractor had to do a lot of costly repairs to get that back up to where it should be. Let's talk about some sequencing solutions. Obviously, we've identified the problem, but now let's look at how we can fix that. So in a majority of cases, as I mentioned before, continuous insulation is typically going to be sequenced after the air and weather barrier. That has to do with kind of where the dew point is in your wall. So the weather-resistant barrier is in most cases going to be put on before any other layer. Obviously, this is problematic because those insulation and cladding layers, when installed over top, those fasteners are going to poke holes through that like Swiss cheese, and you just have thousands of opportunities for air and moisture to penetrate that building. And a lot of times, this sequencing issue just it can't be avoided. You can't put in roofing. The membrane goes on top, so there's really no issues with poking holes in that. But on walls, you have to put the cladding over top, and you can't put an air and weather barrier over top of the cladding. That would look silly. So it's impossible to assess or fix these holes behind the insulation and the cladding with conventional methods. So the main solution here is fasteners, washers, and anchors that have been designed and tested to basically self-seal those penetrations behind the insulation and cladding to maintain continuity of the air and water barrier and support sustainable energy performance of the building envelope. So here is kind of an example of a fastener that has been designed specifically to maintain the integrity of that weather-resistant barrier. So if you look at fasteners 1 and 2, these are used on the exact same product. This is another one of those foil-faced polyiso insulations that I talked about. The anchor number 1, the black one, is going to be a brick anchor with a plastic washer. And then the second one is going to be, it appears to be like a shot-in plastic pin. So it's got a metal pin inside with a sort of plastic cone. And you can kind of see some key differences between these fasteners. You look at fastener 1, it looks like it was nicely installed. It didn't crack or penetrate the layer of foil there to provide discontinuity in the weather-resistant barrier. You look at number two, and that fastener blew through that facer. I mean, it's completely shot. That's going to have to be sealed secondarily with some sort of fluid applied layer or potentially tape. That's just going to be increased labor. You're adding more cost by not using the correct fastener. All right. So I don't know if you all are able to chime in, but we just got a couple of quick questions. You don't have to necessarily answer in the chat, but just kind of think to yourself, what issues can result when there are multiple individual control layers? Kind of what did we discuss before? So some of the issues that can result is when you have multiple layers. We just talked about the vast amount of configurations that are possible. You have different components, you have different manufacturers, you have different contractors. So you're just kind of, it's a recipe for disaster almost. You're just looking at all these different things and how they can be assembled. And this just creates a lot of problems, and assigning liability is difficult because, as I mentioned before, the air barrier contractor installed his layer perfectly, and then the cladding and insulation attachment subcontractors went and poked a bunch of holes in that. So who's responsible for that? And a lot of times that goes back to the designer of record. So we often say that talking with building envelope specialists and consultants is a big way to go, because they know this stuff frontwards and back, and they can often assist with making sure sequencing is done properly. So let's talk about the control layers and sequencing a little bit more. So just going to kind of quickly run through. I'm sure this is a pretty basic knowledge for a lot of you. So after the structure is applied to the building, typically it's going to be framed up. So you're going to use some sort of structural sheathing to support rack and shear. So basically making sure your building's not twisting. You get increased fire resistance, water resistance is kind of some other examples. So what you would commonly see would be wood, exterior gypsum sheathing, could be cement board, or magnesium oxide, which is a relatively newer product to the market, but still quite good. So these are typically just going to be installed with a short screw. There's really no, in a lot of cases, the weather-resistant barrier is going to go over top, so there's not a huge sense in using self-sealing fasteners at this point in the wall. But note right after this is kind of when fastener penetrations become a consideration. So then the next product that's going to go over top, like I talked about, is the weather-resistive barrier. So this is intended to just shed off any bulk water that would get past the cladding, and any vapor, anything like that. So there are several kinds. So typically, wrap would be the first one. So this is going to be like a sheet applied product that comes off a roll and then is mechanically fastened. There's going to be self-adhered, so this would kind of be like a peel stick. The roll would have like a release backer, and then it would be adhesively applied to the building, so this would not use any fasteners. Then you've got fluid applied, so this would be, it could be painted on, or you could use some sort of spray application to apply it as well. And again, this would not use fasteners either. So the next thing that we're going to talk about is the air barrier requires a systems approach to control leakage, into and out of the building envelope. So the integration
Sorry
of multiple.
sorry to jump in, David. Yeah, I'm still on the road. However, one question did just pop up.
Yep.
I've heard MGO boards can be very corrosive, so stainless steel fasteners must be used. Can you confirm or comment on this?
Yeah, so MGO is only corrosive when exposed to water. So if the fasteners are detailed properly and flashed, you would not want to install a fastener into MGO and then leave the head exposed. You would always want to put some sort of liquid flashing over top of that head. As long as that is detailed properly, there shouldn't be any corrosion concerns, because water would never be exposed to the screw once that head is flashed. And if it is, you've got much bigger problems. So I hope that answered that question for you.
Thanks. I hope it did too. It makes sense what you just said.
Absolutely. So just kind of getting back into this, the air barrier is designed to provide a continuous path of air resistance around the whole building. So what a lot of architects and engineers will typically use is a pencil test. So it's basically a method of determining if an air barrier will be effective. And so the designer should be able to take their pencil and trace a continuous path basically around the entire building enclosure without lifting the pencil. So you can kind of see that blue line on this diagram. So this is a big sequencing issue too, because obviously the air barrier components that you would use on a wall are going to be different than what you would use on a roof, and then even different than you would use on below grade. So this just kind of goes to show how important the sequencing and detailing is where these differing components meet. So next we're going to talk about integrated sheathings with the air barrier / weather resistant barrier. So this would be a component or a product where the sheathing and the air barrier / WRB are the same. So a lot of times this is going to be factory applied. So they might put some sort of like waxy coating or a fluid applied air barrier or some sort of hydrophobic agent used in the gypsum to prevent water from penetrating that. So these systemized solutions are really good. They're good for labor because you're not taking 2 trips around the building, you're only taking 1. The issue with these, though, is they do provide some more challenges when it does come to making sure that these are sequenced properly and treated. So commercial applications might use like fluid applied materials on the gypsum after the fasteners are installed. So you can kind of see all these dots over top. All these fasteners had to be treated since this product is being used as the air and weather barrier. So you do have a little bit of added labor cost there since these sheets are mechanically attached. So the next layer is continuous insulation. So this is just defined as insulation that is continuous across all structural members without thermal bridges. So just to kind of help people understand what that means, if you think about, traditional 2x4 framing with open cavities and then some sort of fiberglass insulation put in there, if you take, one of those flare guns and point it at a house that's built like that, you can clearly see the framework of the wood studs being cooler, depending on what time of year, if it's, being air conditioned. You can see that being cooler than the stud bays. And this is because the thermal bridging qualities of wood are obviously greater than that of fiberglass insulation. So you're getting energy escaping through that conductive framing that kind of spans the wall. So when we have continuous insulation, think of like a coat. So it's basically covering the entire shell of that building so that you're reducing thermal bridges greatly. And we kind of got a picture of just kind of a koozie here. That's kind of the kind of fun way that we like to think of thermal bridging. You can kind of see, condensation on the top of that bottle there. And it's reduced when you use thermal insulation because the dew point is pushed further outside of the surface of the can or the bottle. So in relation to construction, that is very important to prevent the buildup of moisture inside walls and prevent the dew point from occurring inside the wall system. Because if you don't detail that properly, the dew point could potentially be where your fiberglass insulation is, and then you're getting moisture in there, which doesn't really have the ability to get out. So you're going to cause mold and mildew and things like that. So this is kind of one of the kind of image that I talked about earlier of a traditionally framed home. You can clearly see those studs are experiencing more heat loss than the stud bays. So a lot of energy codes in America are now requiring continuous insulation. Specifically, commercial buildings is where you see the most. of the continuous insulation being codified, but you would also start seeing it on a lot more residential construction moving forward. And this obviously depends which climate zone you're in. This is going to be primarily geared towards people in the northern United States, but I'm sure it will start branching out to the more southern states as well. So the most common types of continuous insulation that we see, expanded polystyrene. It used to be, one of the more readily available products. You'll see that if you're using like an EIFS system. It's not the best insulator. It's vapor permeable, but it is pretty cheap. So, you might see that on more like tract style homes. XPS is quite moisture resistant. It can be flammable, so some considerations have to be taken there. But that's a good product. It has a fairly decent R value and is readily available in a lot of home stores and things like that. So polyisocyanurate or polyiso is a blown foam. This can be used when it has a foil facer or some sort of facer on top, like you see in this picture here. It can be used as the air and weather barrier, as well as the insulation. It is a little bit more expensive, but it does have a really good R value. And then the last insulation that we typically see is going to be mineral wool. This material has taken off in popularity in the last few years, mainly because of its highly flame resistant qualities. It's vapor permeable, and it allows itself to drain and dry. And then it doesn't have quite as high of an R value, but it does have sound attenuation properties as well. So you would see this a lot in like rain screen type systems that you want to ventilate and dry. And each one is different. So, there might be strengths depending on what your building needs and kind of what you're doing to where one would make sense over the other. So talking about integrated sheathings with air and weather barrier and insulation. So structural sheathing, air barriers, WRBs, and continuous insulation in combination is an example of creating like a systemized board solution. Just helps to reduce labor and increase performance. No matter the configuration, the fasteners always have to be considered. And then lastly, let's just look at cladding and kind of some various types that you might see. So lath attachments for stucco or stone veneer typically require a fastener every 4 to 7 inches vertically and then 16 inches horizontally. And so many of these fasteners are required to attach lath to support its relatively heavy cladding weight. Metal panel rain screen systems require mechanical attachment as well through all the control layers for that like girt and rail or channel system as people might call it. And then we've got, tile, granite, other stone type claddings, brick, things like that that are very heavy and call for, specific engineered anchors to secure that cladding back to the structure. Apart from eaves, most cladding requires fasteners or anchors to mechanically attach the layers. Eaves can typically be installed with adhesive because it is so light. Kind of just another question to think about amongst yourselves. What are the critical control layers for sustainable wall design? So we've got the WRB, air barrier, vapor barriers, and thermal control layers. So now let's talk about why this is important to you and kind of how these things add up. So we talk about the impact of fasteners and anchors. I had mentioned before the damage that moisture intrusion can cause on building materials, how it can reduce energy performance and how it can harm the health of the occupants, and just the potential cost of construction litigation. So let's just I'm going to do an exercise to kind of help us understand the amount of penetrations that you would see when constructing a full building envelope, basically just scaled down to a single, 4x8 section. So let's just talk about how these all add up. So we're kind of looking at the first layer that would be installed. So this is a gypsum sheathing panel. So typically these are going to be installed the screws are installed every 4 inches. around the edge, and then every 8 inches in the field. So dependent on where you are in the country, depending if there's a high wind load requirement, you could see up to 92 fasteners for a single sheet of gypsum. Next, let's think about a mechanically attached building wrap that goes over top. Typical fastening pattern for this is going to be 16 by 16, so that comes out to about 28 fasteners per sheet. So we're already up to 120 fasteners in that small area, and we've only done half of the components. So next, we've got to install our insulation. It really depends on the material and the manufacturer's fastening pattern. Excuse me. But an industry standard for a foil-faced polyiso is going to be 28 fasteners per 4x8 sheet. And now we'll consider some sort of hat channel-based rain screen system. So like a metal channel. And these are also going to be about 16 by 16 inch. And then you also have to use fasteners at the stud intersection locations. So we're looking at about 36 fasteners per 4x8 sheet. So if you're following along and doing the math with me, that's a lot of fasteners. That totaled up to 184 fasteners penetrating through all these specific control layers. And typically, different subcontractors are going to be involved at every stage here. A lot of contractors will say, well, I have my responsibility, that's to install the insulation or the cladding. And kind of whatever happens to the other components is really not my job. And that's a fact of the real world. So if you think about like a small neighborhood Aldi grocery store that I'm sure we've all been into, just looking at their simple building envelope design, it's made with a single integrated component. So this would be a foil-faced polyiso material that's installed directly to the steel studs. So it's basically acting as the thermal control layer, the vapor control layer, and then they've elected not to use a sheathing here. So if you think about just the average size store, that's going to be about 4,000 fasteners to attach the insulation, and then about 6,000 fasteners to attach the brick veneer. So that's 10,000. That's one grocery store, 10,000 fasteners, poking through this control layer. And you got to kind of think, wow, if there's 10,000 opportunities for air and moisture to get in this building, just think about, on a scale of the whole United States, the whole country, how many opportunities there are for air and moisture to get into these buildings. And then even further, how many buildings that have been constructed in the past 30 years have severe air and moisture infiltration issues that we're not even aware of. So talking about the washers that are used to attach continuous insulation, looking at the first washer on top, you can kind of see the geometry of this washer. These are both round, but this one is going to have keyholes in it. And it's got kind of a sharpened, I don't want to say it's sharp, but it's more of a rougher perimeter to it. So when you would fasten a washer like this, air and moisture are going to be able to easily penetrate the keyholes in that washer, and that more rough perimeter is going to shred up the face of that polyiso insulation. If you look at this washer on the bottom, you can kind of see it's purposefully designed where the perimeter of it is smooth and it has a solid cap. And you can kind of see these kind of like cross hatches on the underside of that washer. That helps it be flexible. So when you're installing it onto the insulation, that perimeter is actually going to flex as you're driving the screw as to not tear the insulation and make sure that it seats properly. Looking at brick anchor comparisons, kind of what would be a right product and a wrong product. So these would be two commonly used brick anchors that you would see in the market. The first one would be referred to as a plate style anchor, and you can kind of see these two bayonets, as they would call them, on the end. That's to transfer that load to the steel stud. Since this is a structural component, it's supporting that brick, you have to have positive contact back to the studs. And then they would typically be installed with just like two screws that go kind of just up and below those bayonets. The second product, kind of in the middle, is going to be a barrel style cavity veneer anchor. So, oh, whoops, hold on. What did I do? There we go. So this particular product here, you can kind of see this cut through diagram. It has a polycarbonate tube, so it's going to be very rigid, very strong. And it's got a wedge seal on the end is kind of what that would be referred to. So that wedge, basically when it fastens through that WRB layer through the continuous insulation, it actually draws the barrier material down into the penetration that it just made and kind of crams it in there, so that it's really just gummed up in there and no air and water is allowed to pass through. You look at the metal tie portion. This is required to embed into the mortar joints of the brick to basically retain that brick wall and make sure that it doesn't pull away from the structure. If you notice on the one on top, this is basically metal on metal contact. So you have increased thermal conductivity. So you're getting a thermal bridge there. The one on the bottom, that polycarbonate tube is basically encapsulating the metal screw, and then that metal wire tie does not contact the metal screw, it contacts the polycarbonate tube. So you're getting a thermal break there, so you're not allowing as much thermal energy to transfer through that brick anchor. So you're really getting, kind of a lot of benefits here. So it's a structural fastener, it's sealing the penetration that it makes, and it's thermally efficient. So yeah, as I kind of just talked about before, is the thermal bridging. So you just kind of think about a standard like cast zinc barrel, highly conductive versus polycarbonate with a thermal break, is going to be significantly lower in conduction. So you're going to see a lot less heat loss through the building. And we'll kind of show you in this next slide what that looks like. So this is a picture that we actually took at a corporate outing. We kind of looked out onto the roof from a window, and you can see all these polka dots where that snow would be. So what's actually happening on this roof is that there are 3-inch metal roofing plates underneath that membrane, and the building is being heated, and the heat is actually transferring through those screws into the metal plate and melting the snow kind of where those plates are. So this is just a really great visual representation of what thermal bridging looks like and how it actually affects our structures. So review question, are all fasteners the same? No, they're not. Most fasteners do not seal penetrations of the air barrier. So let's now talk about self-sealing fastener and anchor solutions. So we briefly talked about this product before in a previous slide. So typically for like a sheet applied membrane, you might see like cap nails or staples or something like that used. Those are not a great product simply because they don't provide a lot of blow off resistance and they can corrode. They're just not super great. So if you use a high diameter washer, that has a flexible perimeter and doesn't tear the material, you're going to get a lot better seal of that sheet applied membrane than you would with almost any other product. Similarly, this looks like the exact same product, but what you actually notice here is these kind of 2 prong features that stick out of the bottom of the washer. So it still has that flexible perimeter, so it's not going to tear that foil facer of the polyiso insulation. It's also got a stiffened center ring, so it helps prevent overdrive, because as you kind of drill that fastener in, if you hold down the trigger on that drill, you're going to blow right through the insulation. But with that stiffened center ring, it helps to kind of resist more and prevents the screw head from popping through if there were high winds. And that prong feature that I talked about just helps you pre-spot it on the face of the insulation, so you can actually poke the washer in, and then it'll stay there for rapid installation of the product. If you're attaching insulation to a masonry substrate, whether this would be like below grade in some sort of crawl space, or like the underside of a concrete deck, you could use a product like this. So you'd pre-drill through the insulation into the substrate, insert the anchor, and tap flush with a hammer. This is a fully plastic insulation anchor, so it's going to minimize thermal bridging. And you don't need, any pins or adhesives or anything like that that might have like setup issues if it was cold. Another product that is good for insulation attachment is going to be like a shot-in style pin. And you can kind of see on this cut through here, this pin recesses down into the choke of that fastener. So the thermal bridge is basically pulled away from the face of the insulation, so it's more difficult for thermal energy to transfer. A lot of these solutions are shot in with tools, so they're quick, they're very efficient to quickly insulate the structure. So the next product that's really cool for these sort of applications, it's a newer category of fastener that hasn't been on the market a long time, but they're typically referred to as tube sealing fasteners. So it combines a screw, washer, and a tube to aid in the sealing of those blind fastener penetrations at the layer of the air barrier or WRB behind the insulation or the cladding. So you can kind of see in these lower images, the one on the left shows basically what would happen if you drilled a screw to attach insulation. And as that screw's spinning, it's kind of tearing up the air and weather barrier. You have quite a large hole, bigger than the screw itself, that air and moisture could be allowed to pass through. Now, when you take this tube sealing product and you fasten that insulation down, that tube is actually going to compress over the screw penetration that it just made in the WRB and essentially seal that out. So the air and moisture is not going to be allowed to pass through. So this is a really cool product because you wouldn't be able to treat that blind fastener penetration any other way. But this is just an integrated solution that allows you to not only fasten the insulation, but also gives you peace of mind because you know that the barrier behind that is all sealed up. So I had talked about this product briefly before. So this would be like a masonry cavity wall anchor that combines that sort of tube seal technology. So it has that sealing product or sealing technology via the wedge seal, but it also has thermal bridging as well. So we can also use this tube seal product not only for insulation attachment, but attachment of the cladding systems as well. So this particular product has been combined with a metal washer as opposed to a plastic washer for installing expanded metal lath to receive a stucco coating. So you can take products like that 2-inch plastic washer to install your sheet applied air and weather barrier. You can install the insulation with the plastic washer tube seal. And then you can install your lath for stucco with the metal washer tube seal. So you can really seal all layers of your wall with some sort of sealing technology to really use a boot or suspenders approach to really make sure that's sealed. So next we have rain screen hat channel tube seal fasteners. So this would be for like an aluminum composite panel or a metal panel. So you can attach the hat channel with these tubed fasteners as well. So you notice that it doesn't have any sort of washer on there. The tube basically just butts up to the head of that screw. And then there are pre-punched holes in this channel so that when the screws are fastened through to the structure, that tube is basically compressed on the channel and then serves to keep water both out of the head and then out of the fastener penetration that's underneath. And it also helps resist thermal bridging as well because you are breaking the metal on metal contact between that channel and the screw as well. So how can blind fastener penetrations of the air weather barrier located behind the exterior continuous insulation be sealed? So this is basically, just using those purpose-designed tube seal fasteners to attach the insulation and any other layers to help seal out the penetrations. So testing and specification. So testing is incredibly important. If you're not testing, you're guessing. So you could use a fastener that's been buttered. You could try and use some sort of tape. You could squirt sealant in. Those options may work, but they've really never been tested. You don't know if those things are going to do what you hope they do. So testing is a very key element in the management of moisture and thermal performance when it comes to these walls. So a lot of manufacturers will test their products as a single component, but honestly, what happens more often is going to be an assembly test that simulates real world conditions and would be how things are in the field. Like having loads exerted on them, going through thermal cycling, receiving air and water under pressure to really see how these fasteners hold up and then seal out the air and moisture. So the two main tests that a product like this would go through would be ASTM E331, which is the test for water penetrations, and then E2357, which is the standard test methodology for air leakage. So you can kind of see here, you basically build these test bucks, with the materials required. They would be installed with the proper fasteners and sealed. And then, basically like this, the insulation would be installed. The cladding attachment systems would be installed, and you can kind of see on there are a variety of different materials. So I think if you look at this, we've got basically 1, 2, 3, 4, 5, 6 7 different systems. We're using different air barriers, we're using different insulations, just to make sure that we're accounting for all those sequences and all those potential variables that you on a job site, to make sure that under all conditions these products are extruded polystyrene or in a polyiso insulation with brick anchors. Top third in this particular picture, we've done lath attachment on the bottom, and then we have a hat channel. So the way that we tested this was we built this buck, and then we had basically water that sprays on pull water through the backside of the system. And so if any moisture appears on the backside of this wall while it's being monitored, that would count as a fail. So this product would not be rated to either of these standards. So manufacturers who take their testing to extremes is very admirable. So they go above and beyond the standards. They try and pass conditions that are significantly worse than the minimum, just to make sure that their products are top tier. So this full scale assembly here was kind of referred to as the Frankenwall. It's kind of got a lot of different variations on it, a lot of different combinations of fasteners and WRBs and insulation, and was tested to both E331 and E2357. These sort of comprehensive testing methods provide manufacturers with just a myriad of data points so that they can pass on to designers and architects to give them confidence that regardless of the assemblies that they're specifying, this is going to perform. And then just talking about some real world testing, blower door tests are becoming a lot more prevalent. So I'm sure you're familiar with these as well. Basically entails testing the entire building envelope. So basically the whole building is pressurized, and then the amount of air that is escaped is measured. And a lot of this is now being required to gain occupancy permits. But you got to kind of think, with these thousands, potentially 10,000 fastener penetrations going through those air barriers, what happens if you're not using the correct fasteners? Is that going to cause you to fail one of these tests? But it's a risk that could easily be avoided by using proper fasteners. And then just looking at specification of these products, how are they found? A lot of times, as I mentioned when we started, fasteners are often overlooked, and it's left up to the subcontractor to basically supply what is available or what is most often easiest for them to get. So whatever they have left over in their truck from the last job, and oftentimes that's not going to be the right product. So specifying the correct product up front, so that it's well known what needs to be used ahead of time is critical. So a lot of the ways that these products can look to be specified, there's a lot of tools out there. There's Master Spec, there's Spec Link, Specs for Us. Not that I'm plugging any of these services, but these are just easy ways that streamline the specification process and allow you to search for fasteners like this that self-seal and prevent thermal bridging and things like that. So tips for success, just looking at creating a high performance and sustainable building envelope is just hiring building envelope consultants in the early stages, just to help understand sequencing, material dissimilarities, how to use the proper fasteners, detailing things like that. And just using smarter attachment solutions like these tube seal products that we had talked about, just to prevent air and moisture penetration. The takeaways that I just want to talk about, proper installation and performance of continuous insulation and air, water, and vapor control layers are pretty essential to allow buildings to perform efficiently and free of excessive moisture. When hundreds of thousands of holes are made by blind fastener penetrations in these layers, that can result in diminished capacity and performance, and potentially cause damage to occupants' health. Tube seal fasteners ensure performance of sustainable building envelopes, and without sealing tubes, every penetration is susceptible to leak. And then lastly, fasteners and anchors and cladding attachment solutions tested in complete wall assemblies are the easiest way to ensure sustainable long-term building envelope performance. Well, thank you everybody for your participation. I hope that this was insightful today and that you learned something, and that when you go forward you kind of think about the nuances and kind of the nature of fasteners and how much they play into the role of our envelopes.
Thanks, David. There was one question that came in a couple minutes ago.
Yeah.
I can understand how tube seal fastener seals WRB, water resistant board, which is presumably also air vapor barrier. Aside from proper mechanical attachment, how is the 2-inch diameter seal at the outside of the insulation helping to protect air infiltration or water intrusion? Unless the insulation is foil-faced, taped, and serving as the water-resistant board, AVB, air vapor barrier. Love the initials, thanks.
Yeah, there are
Puts
a
me
lot
to
of
the
them.
test, in which
Yeah,
case it's on the wrong side of the insulation for a cold climate like Colorado. So apparently in Arizona, I don't have this problem. Oh.
Yeah,
A
and
lot
that
of
was a
question there.
great
Did you get
question.
that?
Yeah, I think I got the general gist of it. So the initial question, how does that fastener on the outside of that insulation layer help to promote or prevent rather air infiltration? So that particular product would be used when you have an integrated material, like to where once the joints are sealed and the fasteners are installed, the fastener actually does such a good job of sealing that foil facer, they don't need to be flashed over. So the insulation is in acting as your air and weather barrier with just the fasteners unflashed and then the seams flat. And then in terms of, I think there was a kind of a part two of that question over the insulation. It really depends who you talk to. Some people will prefer to do it one way and prefer to do it the other. I wouldn't really say there's a right or wrong answer, and yeah, it really does depend regionally, where you are, humidity, conditions, how much rain you get. That really affects, what makes the most sense for your particular envelope.
Are all of your products produced in the US and meet the BABAA requirement? That I should just have you ask these questions. Direct requirements we are seeing on projects now.
Great question. Not all of our products are produced in the United States. A large majority of them are produced in our facilities in the States in the Midwest. Unfortunately, due to the nature of steel articles, steel is the most recycled material on the planet. tracking where that was melted, where the actual like raw material came from is very, very difficult. So we cannot with certainty say from one batch to the next if our steel components do meet BABA. We can give you assurances that the material was produced and packed within the United States, but that's about as far as we can go, unfortunately.
That's interesting. Yeah, I do. Probably 90+% of my work is federal, and they have never had heartburn over where the raw material came from, as long as it was the final manufacturer, stamp made in America is what. But I know there's a difference between
Yeah, Build
there's like
America, Buy
two subtle
America is
differences between
pretty.
Buy American and the Buy America Act.
Yeah,
Um,
yeah. And I think there are caveats in there where, you can say if buying the product that has, potentially non-domestic raw material, if it, would increase the cost by X amount or delay receipt of the product by X amount of time, there are some concessions there that can help you access these products easier.
And then Richard Campo, he said he'd love to discuss more offline via email. So hopefully uh, is able to get your email address. David, it sounds like you've got
Yeah,
it.
so this isn't my personal email, but if you see on the screen now, there's that wall sales@truefast.com email. If you do email that funnels basically directly to me, and then I'll be happy to communicate with you offline if you have any questions.
Yeah, and I can get you also Richard's email direct from the
Okay,
other
perfect.
way if
Awesome.
you're good with that, Richard.
Yeah,
We're a couple minutes past the time, but once again, really appreciate it. Great presentation. Glad everyone was patient with me as I was in transit. Um, Hopefully, it wasn't too disruptive for everybody. Uh, with that, when I in the webinar, you'll get that survey to pop up. Just accept it, fill out the information for your certificate, or if you need it to be registered with the AIA, please provide that number. And with that, David, appreciate your time on this. Very well done. And to everyone else, stay safe.
thanks so much. Have a good weekend.